goes from hand valve to a VCR gasket to a filter to a VCR gasket, and then it goes to V40. That's the isolation valve to the right side of MFC. And then it goes to V41. That's the one that branches off. Okay. And then it goes through a VCR gasket, and then it goes to MFC, MFC4, and then it goes to VCR gasket, and then it goes through this valve here, this V42. Okay, this is the left side. Isolation valve, and then it goes down there to V5, right? Okay. Now we already narrowed it down to between V42 and it's really this side of V41, right here, right? Okay. This MFC and this. That's the problem. Okay. And later on, let's say we find out, we're going to determine whether it's this one or this one. Let's say we know that it's, let's say we know it's this one, okay? Then, or let's say we know it's this one, okay? It's shut off, okay? Now that we isolate it to one component, okay, our job of systematic isolation is done. Okay. Now we can use, before you take it out, okay, again, that's a destructive test you want to avoid. You want to first check to see if there is a, you want to check the common failure modes, okay, that you can quickly test for, okay. If this valve was stuck closed, V42 is stuck closed, what would be the most common failure mode for V42 stuck closed? Yeah, pneumatics, right? Okay, because it's a pneumatically actuated valve. Okay, so maybe there is no signal. No, this is a normally closed valve. So when you have pressure, it will open up. Okay, so maybe it's just not having enough pressure. It's just not having pneumatic pressure, okay, to open it up. Okay. By the way, how is our pneumatic pressure doing? It's still not good. Okay. So, so what you can check is, you can take out, before you take out the whole valve, you can just take out the pneumatic signal going there, right here. Okay. And you can feel if there is pressure or not. Okay? If you're not sure whether it's normally open or normally closed, you should try to manually actuate the solenoid, and then you should at least feel a pressure difference. Okay? If you fail to feel a pressure difference, there's something wrong with that pneumatic signal. Okay? Then it becomes a pneumatic system troubleshooting. Right? You don't have pneumatic pressure. What's going on? Okay? And what about this guy here? What do you think for the MFC would be the most likely failure mode for the MFC to be stuck closed? The MFC stuck closed.
It's using electronics,
right,
electrical power, so it would be a
right,
power issue.
Okay, it could be that altogether that it's not receiving power here. Okay, so what you can do is you can have a known good substitution test. Okay, all of these guys have the same exact power source and signal. Okay, the only difference is that they are calibrated differently, which means the maximum voltage. If you apply maximum voltage on the signal here, it might give you different MFC flow rate, the actual flow rate. But we don't care about the actual flow rate as long as it flows. Right now we don't have any flow at all, right? So we can actually substitute one out to the other. Okay, if you know there is a known good one, let's say gas tube, you know it flows. Okay, these cables are long enough so that you can unplug the 4 and then you plug in the 2 on the 4. Okay, now you see if it flows. Now, as I said, when you do this test, make sure during the swapping you power down the etcher first. Then you do the swapping while power is on. Okay, you can't hot swap. Okay, and if you do the hot swap, which we've done before, and discovered the hard way that afterwards the flow was not accurate anymore. Okay, and so make sure if you do that test, you power off. Okay, and then let's say you try out some most common failure modes. Okay, including you can actually disassemble a valve. Okay, part of the valve that pressures in and out. Okay, you can take that apart and take a look and see if it's pressuring in and out. Even that, you can't rule out the fact that even when the stem is going in and out, that the valve, there's an O-ring being stuck somewhere. Okay, but let's say you find out it's doing okay, but you can't find anything else, then it's time to take it out. Because it's just one component, it's easy to take out. Okay, so let's say we have to take this one out, the MFC out. Okay, well, how is it mounted? Well, you see that it's on one side has a VCR, on this side you have a VCR, right? Okay, that's how it's sealed. Okay, so what you got to do is you're gonna have to shut down both side ISO valve. Okay, because remember this can have toxic gases in a factory, right? Okay, so what you do is the first thing is you pump out the line. Okay, remember you can do a pump, you can pump down the line, and you can purge the line, the reverse purge and the forward purge. You do that, many cycles to get rid of the toxic gas. Okay, and then what you do is you close the isolation valve on this side, you close the isolation valve on this side. Actually, before you close it, you should pressurize this. You should pressurize the whole line. Okay. Then you close the isolation valves. Okay. Now you have pocket of air already inside. Okay. Inside this section. Okay. Then you loosen these fittings. Loosen the VCR fittings on both sides. Okay. And then you can take it out. When you do VCRs, okay. Remember how we learned in the vacuum class that VCR fittings, sometimes they make it such that, always you have two nuts on the VCR, okay, and they're both hexagonal shape, okay. So you gotta use 2 wrenches, okay. But a lot of times they make it such that only one of them can turn. Okay, the other one is welded to the pipe. Okay, so if you actually try to turn that, you can crack that welding and therefore create a permanent leak, and that's hard to fix unless you actually weld back together. Okay, so don't try to turn that. Okay, you got to examine which one the system allows you to turn and which one it doesn't allow you to turn. Okay, in this week's homework, you're gonna have to do that. A lot of you guys will have to do that. Okay, make sure you identify which one is. Okay, that can be turned. And then you put the other one, you make that stationary, and then you turn the one that can be turned. Okay, you loosen it. Once it's loosened up, you use your hand, turn it, take it out, okay? These guys are so tight, the geometry is so tight that even after you take out the nuts, okay, this MFC is still stuck there. Okay, so here's the thing. You might have to create a little bit of a room, okay, because this is the MFC is jammed in together on both sides, okay. So to create a little bit of room, you might have to loosen up. You see how these things are all mounted on blocks, base plates. There's a base plate right here, and there's a base plate right here. Okay, it's mounted on the back wall. Okay, and they're screwed tight to the back. Okay, so if those base plates don't loosen up, okay, then it's still, these guys don't have any room for wobbling. Okay, so what you might have to do is you got to study which base plate. You might have to loosen one of those base plates. Okay, and then you might have to use a mallet. Okay, and you have to tab on one of those base plates so that it distances itself a little bit away. There is a little bit of a flex in the steel pipe. Okay, just enough so that you tap on it a little bit. Okay, then you have enough room. Okay, and then make sure someone is there to catch it. Okay, and then that thing will drop. Okay, the MFC itself won't drop. It's just that the fittings, because the MFC is mounted on this base plate. Okay, the fittings will. Okay, not the fittings, the gasket, the VCR gasket. Okay. If you study vacuum, you know that there's the metal gasket, metal O-ring. Okay, nothing will fall off. Okay, which is what you want. And then you take out. Then what you can do is you can dismount. If you want to check for, a lot of times Robert would put blank offs at those fittings. Okay, so once you take out the fittings, you can take a look. Is that does the fitting actually have, does the O-ring have a hole, or is it actually a piece of metal that blocks the whole thing? If it's a piece of metal with no holes, then you know, well, that's your problem, because that blocks the whole thing. Okay? But if that's not the case, you might have to take out a valve and inspect it to see, make sure there's something, something blocking it, not allowing it to open or something. Okay? And of course, in reality, if you can't find any problem with your MFC and you suspect, and you test it out, the MFC cannot open, that's the time to swap it out with a non-good one. Okay? And then on the installation, okay, you got to remember, first of all, the MFC is one. It has a polarity. Okay? When you install it, make sure it faces the right direction. And there is an arrow there. And the second thing is you got to make sure that when you mount the VCRs back together, okay, we learned this in vacuum class that there is a need to change out that gasket every time. Because it's a metal gasket, it doesn't really bounce back. Okay, so once you use it once, that's it. Okay, you can't use it again. So you got to take it out. Okay, you got to put a new piece, and we have plenty of VCR gaskets at the front, by the on the podium, new fresh gaskets. Okay, and then you can mount it in there, and then it might be a chore to try to mount that one in again because of tight geometry. Okay, and then once you mount it in there secure, then you hand tighten the nut. Okay. And then you use your 2 wrenches again, okay? And then you turn the wrench until it's snug. Okay, that means that snug is a point where if you turn more, then all of a sudden there will be a lot more resistance. The amount of resistance will just go up by a lot. Okay, just right before that point is called a snug. Okay, and so you turn it until snug, and then from there on you keep track of how much you turn. Okay, and for VCR gasket, you are allowed officially to do 1/8 of a turn. Okay, that means 45 degrees. Okay, if you do too little, it won't seal tight. Okay, if you do too much, remember the VCR gasket got those B protrusion flanges. Those are the ones that dent the soft O-rings. Okay. If you do too much compression, that B protrusion can be damaged, and later on it won't seal tight. Okay. So you can do 45 degrees, and you can go beyond that. There is some room. Okay. So you can do 60. 60 will be one phase change because this is hexagonal, right? Okay. So if you change from one face and then you rotate all the way to the other face facing the same orientation, that's 60 degrees. Okay, you should stop there. Okay, if you go above 90 degrees, if you go to 90 degrees, there is a danger that if you do this repeatedly, that flange will be damaged. Okay, and for VCR gasket, you actually have to check the spec. Okay, for ours it's 45 degrees. Okay, it depends on the fitting type. I mean the gasket type. Okay, if it's made of nickel or is it made of copper, then it's different. The spec is different. Okay, but for ours it's 45 degrees. You can do 45, you can do 60, but don't go to 90. Okay, it'll be too much. Okay. In the fab, once you seal that, you guys actually have to check the seal integrity. Okay, if it's a non-toxic gas, you do a rate of rise test. Okay, with this open to the chamber. Okay, see if there's any leak. Okay, if it's toxic gas, you actually have to do helium leak check. Helium leak check.
Oh, okay.
You spray into that the two new fittings you make. Okay, and then you use helium detector, and you see if there's any leak. Okay, so we're actually not going through this because we don't have time. It's going to take a while for this disassembly and assembly. Okay, but I'm walking you through this. I was walking you through the steps. Okay, all right. So now, if you pump down 10 minutes, it should be plenty.